Thank you. Okay, so I want to teach you about this Jtag Programmer. Well, Jtag or SWD, those are all equivalent expressions. So we made it as simple as possible. Chris designed it, so big round of applause for Chris, because it's the cleanest design we could possibly have. So really, I'm really happy to see this. So all we have is an ARM chip here. It's an SAM D11C14, and it has these 4 pins to program a target. And also you can program the chip itself, but you only need to do this once actually. So optionally you can skip soldering this one, because you can simply touch the 4 pins during programming. I wish we had tried that. You can try it maybe on today. And so if you look closely, you have these little dots. And what this dot tells you is this is the ground pin. As you can see, the orientation is the same on both. So this is quite convenient. If you want to program, let's say, the same board, then you just put an IDC connector from one to the other with the same orientation for the cable. Yeah? So let's do that. I've got them here. So I've connected the outgoing port to the incoming port of a target port. Yeah? Alright, so that's basically all I need hardware side, so I can just connect them now. And you probably need a help, because sometimes it's a bit hard to have enough room. So this looks a bit funny, but there's no reason it wouldn't work, right? I plug it in, and let's see what my computer says. Right. So I go to hardware. Well, there's a lot of stuff, but here is my programmer. Okay. So the question is, how do I get there? How do I program the programmer? Does anyone have one of these so I can use it for a second? Thank you.
How does it show in the device manager? In device manager, how does it show?
You mean as what?
In the device manager.
How it shows?
Yes.
Like this.
Generation.
Yeah. So, let's program the programmer, shall we?
Can you do mine, because I will leave?
Okay.
I'm sorry.
And so,
you can do.
is yours pre-programmed or you don't
I'm
think
not
so?
sure.
Let's see what
I'm
happens.
not sure whether it works.
So those chips are very simple. If there's nothing on it, then it doesn't communicate with the USB pins, so it will simply not appear. Let's try. It does appear. It works perfectly fine.
Okay.
I'm sorry. Yeah, this is kind of awkward. I have two debuggers now, but okay, I'm gonna erase one of them. So, as you will see in the documentation, so the command for that, for programming the programmer, is this. We use EDBG, which is made by Alex Stardoff. He's a great programmer. I really like him. This is the GitHub page for that. You get the binary of EDBG right here. Okay. So it's linked in the back. That's right. So once you have EDBG, this is the command to flash the programmer using another programmer. So at first you might need an HTML ICE or something else, or someone else's programmer. That's kind of the point of this bootcamp actually, is to give each of you your initial Jtag program. So in my folder I've already prepared EDBG as well as the binary that we want to put on there. This binary is all you need to flash on there. So once you have done this, it's going to be ready to use and it's going to stay like that forever. Okay? So let's list. Yeah. So right now I have 2 debuggers. I have to pick one of them basically. Let's remove.
Can you use mine to make sure it works?
Yeah, sure. So as you can see, I just unplugged yours, and it was listed as the C54, wasn't it? So I'm gonna use it as a programmer, and I just connect them. Oh, sorry, it's the other way. So like this. This is backend's programmer. This is my programmer. It's gonna receive.
Show it closer to the camera. Like for a second.
This is good. So the left one is the one that is programming, and then the right one is the one that is being programmed. And yeah, so the alignment has to be matched. So for the IDC connections. Okay, that's enough. Thank you.
Thank you. Put them in. Okay. Let's list them again. Yeah. So I will simply follow this command. But I will also specify which debugger to use, which is a good thing to show you actually. So you do -s and then the serial number. Okay, so this is backend's serial number. Oh, sorry. EDBG.exe, because I'm on Windows, sorry. And that's it. It's done. Something else you could do is simply erase it. Why not? So for that you only need E. E means erasing. And there you go, it's erased. So now in principle I should only have one of them. And if I list them here, because I just erased the software, there's nothing running on my programmer right now. But if I flash it again, now it's working again as a programmer. I have two. Okay? So it's really as simple as that.
Can you show the command window again?
Of course. So this is what I used. And this is the serial number. You can omit it if you have only one debugger attached. Okay? Okay, so next, let's program something actually useful. So let's program the programmer for the other family that I wanted to show you. The UPDI family. So those are AVR chips, and they use this beautiful one-pin only protocol. Just need this pin to go to the AVR target, and it's really as simple as that. Just two pins. Here you see there's only one UPDI pin on the target. On the host, you can just use a serial port with TX and RX, connected together with a resistor. 4K7 is the reference. We used 5K. It was fine. So don't worry too much about the exact value here. The concept is more important. So as you can see, the RX pin is going directly to UPDI, but the TX needs to be protected by this. Anyone has any idea why? Why it's this way and not the other way, for instance? So think about what will happen with this pin. The chip has only one pin to communicate. It's going to use it for receiving data, but also for sending data, right? And when it's sending data, there might be a clash with the value of this. In fact, there will be a clash. Because, as you know, the serial TX pin by default is at high level all the time. But then it goes low when it wants to transmit. So TX will be high all the time when the programmer is listening to the chip. And what would happen if the chip wants to send a low value? Then you have a low connected to the high. That's very bad. So that's why we have this resistor here. The way I always remember it is that the TX is a low impedance pin and the RX is a high impedance. So there's no problem for the RX to be connected straight away, but you need to protect your TX pin with the resistor. Okay, so this is our programmer, and we thought for a really long time about what's the best pin mapping would be here. And we went for this 2x3 connector. And the reason is Neil uses always 2 pins or sometimes 3 pins, but he uses horizontal pins, and this can snap off really easily. And we wanted a durable programmer, so we went for a vertical header. We could have used 1x3, but 2x3 is much sturdier. And there's this nice feature here that we have. It's symmetrical.
Yeah.
So like USB-C, you can connect it both ways.
You can make mistakes.
We are pretty proud of that. You cannot make mistakes.
Particular things. If it's strong enough.
So here's something really nice about this board. It uses an SMD. Okay? So we need to program it using the programmer we just did. Okay? Because this is an ARM processor. Why did we use this kind of chip here? Because it has native USB support, and this is amazing. You'll see that in a moment. So now the target will become my UPDI programmer. I just follow the dots as usual. I can use any that's here. I have plenty, I have 3. And let's not be stupid about this. Okay. So does this look right?
There's a minimum distance. It has to be a bit right away. So yeah, the left one is the programmer, the SAM D11C SWD programmer, and then the one to the right is the target board or the SAM D11C UPDI programmer with a 2x3 connector here at the end.
And I have this thing. This is because I already have a program on my UPDI board, but that's fine. Let's erase it. If you already programmed it. And you don't need a file when you're erasing. Okay. So now it's gone. It's dead. There's nothing on the chip. So what are we gonna put to our firmware on this chip? Well, let's look at the dock. Oh, we're gonna put a bootloader this time. So it's not the whole firmware, it's just a small portion. It's only gonna use 4K out of the 16K available on that chip. And we're gonna use the bootloader from the amazing new Fab SIM core that I now maintain. This is actually from Mattertech. I just took over to do some bug fix, and now somehow I'm in charge of it. So let's look at the repository a little bit. So first you have the instruction how to install it on the Arduino side. So all you need to do is go here and you add this JSON URL here. Okay, it's the first line. Once you've done that, you can go to board manager. It's always a bit slow, you need to be patient. If you look for Fab, this is the core, okay? You can select a version and install it, but I already have it installed. This will let you program this SIMD using the Arduino software. So, you know, we're gonna have codes in the sketch and launch it to this chip using only the USB port. I'll show you, it's just amazing. But for that you need the bootloader. Bootloader's job is simply to be responsive with Arduino whenever it wants to program through the USB port. Okay, so the bootloaders are all here, but there's like a lot of them, so you need to find the right one. But for your convenience, it's already linked here. Okay, so this is the SAM bootloader agent for the SAM D11C 14A. Okay. Alright, so I already prepared it in my folder here, as you saw. This here. So let's simply send this to my UPI board. Yeah. Okay. It's the same procedure as before, but the file is different. Now it's the Samba file. And it works. So what's going on here now? We have this guy. And believe me, I put a lot of work into this USB driver to make sure it's called the correct way. Because before that it was very strange, the names it could receive. And you will see it in Arduino now. It always has the correct name. Okay? So what do we want to do now? We could do anything. We could do a blink, but there's no LED on this board. So what's the point?
Let's do blink.
We're going to use it as a hardware serial port, USB to serial. There are many ways to do this, but here's the one I prepared. Very, very simple code. It only sends characters to the hardware serial pins, and it goes both ways. So if there's a character on the serial pin, it will send it to the computer and vice versa. But the other thing it's doing is it's constantly checking the configuration for your USB port. So you can dynamically change the baud rates, the parity bits, the stop bits, and even the data bits. I didn't know that, but the serial protocol supports more than 8 bits words. It's interesting. Anyway, it's yeah, let's have this code. Oh, I'm just gonna copy paste it. I'm lazy. And let's send it to my chip here. So that's the code. Need to save it. Ah, it's already there. SAM D11C. And now, because I already installed the Fab SM core, it's ready, and you select this one. Let's look at the options, whether they are reasonable or not. Yeah, there's no crystal on this board. It's using the USB for cadence, or the internal crystal if it's not connected to a host computer. And look at that, USB support. So right now we're only going to use the CDC. CDC simply means USB serial. It's a serial port over USB. But you can do many incredible things. Look at that, CDC HID. Anyone knows what HID stands for?
Human interface device.
Exactly. So if I select this, then I'll be able to declare it as a keyboard or a mouse.
It's a great hack.
Yeah.
Hey, but you can also use it as a regular FTDI.
Yes. This is CDC. So let's do that. I need to select 2 serial ports. This is explained here, and this is simply because the pins that we used are not the main ones. You have two hardware serials basically. We use the second one, so you have to select that option. The bootloader, we do have a bootloader. It's the 4K one. It's preloaded. It's ready. The PWM frequency, we don't care. The correct serial port selected. and let's send this little program. So right now it's complaining. %82%. So as you see, 16K is really not a lot of flash, and we almost use all of it already. But it's not so much the fault of this sketch, it's the fault of the whole USB implementations. USB is a really heavy protocol.
To recap, so you it is a two-step process. First, you use the SWT programmer to program the UPDI programmer to burn the bootloader.
The bootloader, yeah.
And now you are uploading a specific kind of functionality code using USB already. It as a USB port.
Absolutely. So at this point, I can simply remove my Jtag Programmer because it's a self-sufficient board. From now, it can be programmed through USB. Let's do it again, actually, just to prove it. So just this board, connected to USB, EDBG as a serial port, and because we have the bootloader on there, it can simply be programmed through USB. And this is really nice because think about how the Arduino works. On the Arduino, you have this AVR chip, but next to it, you have USB to serial chip because otherwise, it's not going to communicate with the USB at all. You can do a dirty hack of implementing USB in software on AVR chips, but this uses so much flash. It's very
Like the mini
very
code
dirty.
library.
Right?
The mini code library.
Yeah, yeah. I've seen people do it. I'm not too familiar because I rather use, hardware that supports USB already. And here we go. So now nothing changed, but it's received the program. So one thing we could do is go to the serial port and let's think about it for a second. We have RX and TX are connected together with a resistor. So if I send data, I should see it coming back, right? Let's see. Yes. So I think the type here is going to come back. And the amazing thing is you can change the baud rate to whatever, and it does work indeed. If you will, it looks like nothing changed, but if you look at the scope on the hardware pins, you will see the baud rate indeed has changed.
The
So
program that you just uploaded, it's sort of the hello echo thing.
it's a hello echo, but that does dynamic baud rate change. That's really all it does. But the echo part is indeed just here. It's not an echo though. It's not an echo. It's a USB to hardware serial. And because we connected TX and RX together, it acts as an echo. Yeah. But UPDI requires that. You need to connect TX and RX. And when you look at the when you actually use the programmer, using whatever, using BioMCU Prog, BioPDI, some of you might have already used, or even now you can do it through the Arduino IDE, and I will show you that in just 5 seconds. That these programs, when they send data, they know that it's going to come back, so they just ignore those bytes, and then they read the reply from the target AVR. Yeah.
So we could make a fork of this one and use it instead of as a UPDI programmer as a FTDI.
Absolutely, yeah.
Because for example, right now there is shortage of FT230, which is like 3-4 months.
Yeah.
It's impossible to find. So actually we could use
But
this.
the-
It's easier to solder, way easier,
Yeah.
because with this spacing.
So this is the reference design for that.
It's
Just
amazing.
Niels board, which gives you 6 pins. The standard 6-pin FTDI.
Okay, that's correct.
And we use exactly the same code.
Okay, problem solved.
Okay,
Can't we combine boards?
combined. What do you mean?
All-in-one UPDI, FTDI.
UPDI, FTDI?
Oh, absolutely. Well, I mean, this is already a UPDI programmer if you just add the resistor. Right?
Yeah.
So
Yeah,
Neil has that. It's ready for you if you want. But the reason we made this project anyway is, well, there are 2 reasons. we wanted everything on one board, so it's, you know, just grab it and go for programming, and we have this nice symmetrical connector, so that was our reason. But you're very welcome to use Neil's version of that, which is this, if I'm not mistaken. Yeah, just add this on top of
Adrian changed this one and included the VCC trace also last year, I think.
Oh yeah.
But the other Arduino
It's,
Arduino has 3 pins, right?
Yes.
yeah,
that's fine.
it's-
Yeah.
It was listed there.
I think it's also available here. Yeah.
Yeah, see,
3 pins.
we are,
So, in all of those cases, the chip that's actually doing the hard work is the D11C, and you can use my codes to have dynamic baud rate changes, which is kind of nifty. And if you look at the properties for this device, it's a COM port. It's a proper serial port. I think you can even change the baud rate here. Yeah, baud setting. Look. So this shows you that the OS is communicating with the device to set the baud rates. It's part of the CDC protocol, so the serial over USB protocol has all of that planned already for you. Okay, so I know it's getting lengthy, but I still want to use this programmer. It's going to be very quick, don't worry. So I have an EVR target chip ready here, and I'm just going to pull 3 cables from there. There's the ground, there's the VCC to actually power it, and there's the UPDI pin. I'm going to connect them, then you can show it. Okay. So.
Alright, so I just see this fine. So okay, so here we have the UPDI programmer on the left, and there's an Arduino on the right, and so you see that there are 3 cables. So one is VCC, one is ground, and then the third one is UPDI. And we are going to attempt to program it using one of our new D11C UPDI programmers.
We're gonna load a little blink program for this cute little Arduino. So I'm just gonna power the programmer, and this one should already receive power right thanks to the VCC pin. You know, the cable doesn't provide just the data transfer; it's also powering the target board. This is a nice property of EVR chips. You can argue that it's much simpler. You just need to power it. There's no USB, etc. You could also do that on the same D, but that would be a waste. So now my serial port is still there. Nothing much different, but we are using a completely different Arduino core. We're using the Mega Tiny core this time, which you might be familiar with, you might not be. So let's look at Spen's code. That's his amazing work here, Mega Tiny core, and it supports all of the new families, Tiny EVR 0, 1, and 2. And if you want even better chips, you have the DX core, which supports the EVR, DA, and DB. And those are very recent. So as you can see, Atmel is really going to UPDI for everything now. So it's really worth it. So, Blink program using Spen's Mega Tiny core. It's a 1614, I'm being told. And let's look at the options. Yeah, it's perfect. No need to change anything. And look, the serial port this time. It's my programmer serial port, because it's the only thing connected to my computer, yeah? But if I'm going to select this. So this is what Spence and I have worked on for months. And the result is you have the UPDI protocol directly in Arduino core. let's use the slower speed. It's more reliable. I assure you it's very fast anyway. But let's run the program. Whoops. The compose is busy on another window. So now it's compiling again. And then I got this is our little code that sends the data.
It's bleak.
And it does blink.
It's alive.
But that was quite simple, wasn't it? I mean, in the end, when you want to program a chip, just select the port, serial UPDI, you're good to go.
I do have to say that so far this is the best reason I have ever seen to use Arduino IDE.
And you,
It's always the programming the ARMs. They're
you
very
hit the two
convenient.
configurations
It's
where you
super
say
handy.
slow.
You want to try another speed? Sure.
How about
No, I don't have
do you
that
have
many
a board with the
You don't?
6-pin?
You might need to update.
Maybe.
Yeah.
Is this like a board with a 6-pin UPDI connector?
No.
Or not yet?
Okay.
So yeah, we are missing a whole board with that.
Okay, there's one last prototype feature I wanted to show you. Remember EDBG
Can you send me
to put the bootloader? That was quite annoying, wasn't it? So I made an integration here.
Yeah.
Let's simply try it. In principle, you can load the bootloader using the Jtag Programmer as usual, simply through the Arduino core. Let's try. So obviously you have to select the SM core and we don't care about any of these options because all we want to do here is burn the bootloader. Let's still select EDBG and look at that. It worked. And now
Yeah, it's really awesome.
so no need for EDBG if all you want to do is load the bootloader, the standard bootloader. You can simply do it from here.
And the Untitled EDBG is installed.
Yeah, it comes.
Arduino IDE.
It comes with the package. Don't worry about it.
Okay. No, it's more that students don't have to install EDBG separately.
Yeah, but again, as long as they have a programmer, they don't need to do it anymore.
Yeah.
In principle, it's documented here. It's explained. That looks good. The wrong one, sorry. VDI. When you flash the bootloader.
Okay, with this you can also do straight from the Arduino IDE.
Like this.
Yeah.
Yes, and when you do this flashing bootloader, it still doesn't show as a console. No? For that you need to.
No, it's right. Sure. Let's prove it. Let's prove it. So I'm just gonna erase it. So no more compounds. It's just my SWT programmer here. And let's use Arduino this time for flashing the bootloader. The comport is a weird phantom. It shouldn't be there. Doesn't matter. Look at that. It's there again.
And now to use it as a Jtag programmer, you need to load the code.
You still need to load codes to actually use the serial ports. It's still annoying that it's a two-step process. We can perfectly make it a one-step process.
No, but it's good because it makes a difference to understand
Yeah.
that bootloader code is not the same.
Yeah, I agree.
I think it's better in stay like this because it's easier for the students to see the different steps.
Yeah, because this bootloader, they will also use it for many other things. Right, so,
I have a question. Like when we have the programmer, like it shows up in the device and printers, but not in device manager. Like what? Like I don't really understand.
Oh, a typo, sorry. Tell me?
Yeah, it shows that the generic SIM MSI stuff
Yes.
shows here, but not in device manager.
Not in device manager?
No, that's, or at least not in my computer.
Ah, it should. It's in imports. No, not import. Actually, you know what? I have no idea where it should be. But it's somewhere.
Yeah.
Somewhere for sure.
By the way, one thing is confusing for me. So when you burn the programmer code on the programmer board,
Yeah.
so the Arduino is not is ignoring it
Of course,
automatically, right?
this programmer, the SWD programmer, is not even a serial port. It's a weird thing. It's not going to show up in any way. So,
Okay, but then anyways, like using EDBG, so when you erased it, I think for the last time you didn't specify the serial number.
No, because there was only one, right? So it's the same here. There's nothing connected to it. I can still use it, and it's going to complain that nothing is connected.
Because
But if there's a target,
so of course you need a programmer, and then if there's a target, then it's going to erase, of course.
yes.
Keep it all, and then you erase it, and then the Arduino it only accepts, it only targets the board which is empty. Which is erased.
You know what? No. It works in any case. Erasing bootloader is something you can always do if you want to start from scratch. Just you can do it from the Arduino Pro. Doesn't matter.
So now both of the boards are connected. So which of the boards is Arduino detecting?
None of them. Sorry, I just programmed it so it appears again. But let's erase it and look at that. No boards. That's because the SWD programmer is just not visible. The other one doesn't have code on it yet, so there's no serial ports right now. But if I burn the bootloader,
Okay, the Arduino, you can use the Arduino to burn the bootloader on any board that is connected and that is not a programmer.
yes,
Okay. That was my question.
yeah, it's a very good question. So the distinction is, if you want to program a programmer, you don't care about the bootloader, you don't want one, so skip that step entirely.
Okay. So Arduino ignores the programmer.
Yeah, it doesn't know much about it, but this will detect it anyway.
But
This
yeah.
And as I said, I can still burn it again and again. It's a valid way to start from scratch. So, yeah, I'm sorry I had to mix two families. I wish I had, I could have done that in 2 separate days. Because right now, I'm sure a lot of concepts are completely mixed in. But, read the doc. I think it's nicely illustrated, at least. We need more text. We need more contributors there. So, if you try it yourself, please consider contributing to this so that we have more knowledge about what could go wrong during those steps, yeah?
And later today, I'm going to upload the latest version of the UPD 230 one. So if some of you have more, the FPDI chips at the lab than the D11C, like I do, then it might be interesting for you. And I just finished routing the 6-pin connector. Uploaded it.
Very good. Okay, so while I still have your attention, I want to get you. I want to get you more excited about what the SMD chips can do. So here's a little piano, and I had a horrible time putting the bootloader on there because it turns out Alex didn't yet. He doesn't yet support this chip. It's an SAMD11C. Doesn't support it yet. So yeah, officially here, if you look at the code, and it's really no secret, the code is just completely explicit about that. You will not find the SAMD21 J. You see? Nothing. It's just not there. let's look at my fork, because I have to fork it in the middle of the night to fix this bug. And in my fork, wait a minute, something's, it doesn't do this. Okay, so this is the one, this is my addition, yeah. He didn't have that. If you look here, he goes straight from 17D to the 18, and I have to add this one. Anyway, lots of trouble, well, really not much. But let's burn the bootloader on this piano, shall we? It's connected, and this time it's 21, which is really my favorite flavor of chip, because it has, I told you the D11C has 416K of flash. The D21 has 128K of flash. And there's an 18 variant that has 256K of flash. So this is getting quite significant. They cost a few euros each, but still really worth it. And let's flash the bootloader, but this time it's an SAM D11C 17A. And it works fine.
Record the process, but it starts pointing and working.
And here is some free touch example, because we wanted to explore capacitive touch, or step response we also call it. And using the Adafruit free touch library, it's extremely easy. It's right here. It's not an Arduino thing, so you need to install this library as an additional library here in Arduino/libraries. And it's simply set up like this. So I have to set up one Adafruit free touch object per capacitive pin. Right now I only have one. And then you have to set it up, begin, it could fail. And then measure, and you get the value. So, you know what, let's go to debug instead of the final application. And again, I can now remove my programmer. It has done its job. And this is a standalone chip from now on. It's like a little Arduino. Okay? I'm going to select the X21J and make sure this is the 17 variant. Yes. Everything seems pretty correct here. The serial port, and flash it.
SAM 11 has also the capacitive touch.
It does. It's really great for that. It has many features.
How many pins do you have capacitive sensing?
So I picked the J variant because it has 64 pins, and among that you have 16 capacitive pins, which is huge. And for a piano, you need 12 semitones. So there was no choice.
And having the capacitive touch ability means that you can change the pull-up resistor, is that it?
Absolutely. So you have all these options here. We use 4 sampling and a 50K resistor, but you can change this. It's amazing because it lets you sense many different values of capacitance. But let's use this for now and see what it says on the serial monitor. I've put a bunch of prints on the serial USB. So let's see. Okay, there's a value here, and let's put my fat finger. Yeah. There's clearly a difference. So if I detect this difference and display it on the LED, I have a little functional prototype here. Yep.
So this library only works if you have a capacitive touch pin.
Yes.
In theory, you could use any pin if you added the right resistor and things like that.
Oh yes, you can do step response by yourself. But I really like the fact that they have it all embedded like that. It's such a joy to use this in this fashion. As you can see, there's an ABC and everything. So for sure, it's much more sensitive than if you were to do it from scratch.
Yes, you can change the resistor
Yes, there's
adapters.
There's a set of values for the resistors, but I'm not sure where we could find the list.
It's going to be
Probably.
one more. Keep pressing the first key and
Just to change the
LED
sensitivity.
turning on. Maybe you can capture that.
So now I say my goal is to make it a Midi compatible device, because remember, this chip supports the full USB stack. It could be a keyboard, or it could even be a Midi device. And if it's a proper Midi device, then it could be used with music software. So let's look for an Arduino Midi library. And look, it's totally possible. Surely there's a library for declaring a Midi device. Look, Midi USB. So yes, I can make this a real piano. So I'll take a bit of time to try to get that running, because I think it's funny. Questions?
No. Yeah, I have a question regarding serial USB.
Yes.
So I see you used serial USB prints, but what function would you use to get commands from the computer, from the USB serial? Is it
Read.
similar?
Read.
Something?
So if you do a serial USB.read,
Okay.
you get 1 byte.
1 byte? Okay.
Yes, I think it's a blocking function.
Okay.
Ah.
It probably doesn't have enough memory
Read incoming serial data,
or code to make some entries.
and you get just 1 byte. So if you want a sentence, you're gonna need to accumulate them in an array.
Serial, it has read line, if I remember correctly.
Might be, yes, read line. Yeah. Good point. Read string until, yeah. This could be a smart way to do. If you have a new line character, here, you could have just a new line, and you read until a new line character, and you have your little command from the PC.
Okay.
As simple as that. Okay, well, that's really all I have for you. I think it's still a lot to process. But if you have any, and I really mean it, any application that could be fun with USB, you can do it with an SAM D chip. You can do a fake keyboard. I have one here. So this is hacking USB stick. It pretends to be a keyboard, and then it types really fast nefarious commands. So and there's no protection against that, because how could the computer refuse a keyboard? The only protection would be limiting the keystroke speed, so that you could not type too fast and inject script and stuff on your PC. But that would be frustrating for the user with a limited data rate. So
You're still somewhat limited by the user's rights on the computer.
Yeah, but on Windows, basically you're an admin. So this is a Windows oriented. Actually, do I have? I think I can just plug it in and show you what it does. My goal is really to get you guys motivated about those SAM D USB capabilities, because I think it's underrated. See what happens.
We should have one of these in every pub.
Can we make them?
I mean, I have the, of course, I mean, I didn't share the project yet, but it's right here. It's you can have one.
It's nice you have it carried in the pocket, and whenever you see an unlocked computer, and then you tell, hey, look at this, you know, I can hack your computer right now. So plug it in.
It's how you program it, and this one is a recrawl. It will send you to the recrawl YouTube video.
Go back to the serial monitor.
Yes.
Serial monitor. Ah, when you plugged in no, the
Open
the
to
pop-up,
text.
the open.
The text file.
Yeah. It's a typo.
Yeah, I know. It's because it's typing too fast. It's a bit too motivated right now, so it's typing one keystroke per millisecond. That's a bit much. But yeah. Yeah. Really fun, isn't it?
That's fun. So you convinced me completely to switch from